Hello, Advanced Geometry. So today we are going to talk about how to write a proper definition and classifying angles and types of lines. So a definition has two parts. You first need to classify the object. So what type of object is it? Then you have to differentiate it from objects that are in the same classification. So for example, what is the definition of a protractor? So a protractor is a type of tool, and what that tool does that differentiates it from a wrench or a drill or anything like that is that it measures angles in degrees. Okay, so that would be an example of a proper definition. Another example would be, well, what is the definition of a square? So it's classified as a special type of polygon. And so it's a quadrilateral. It has four sides. But it is a special type of quadrilateral in that it has, so it's a quadrilateral that has four congruent sides. And we'll talk about if that's enough information here in a second. So once you have written a definition, you should test it. So to do this, you can try to come up with a counterexample. So if you come up with one counterexample, that makes your statement false. So counterexample that fits your definition but isn't what you were trying to define. So for example, try to come up with counterexamples to the definition of a square that I wrote above. So pause and try to come up with a counterexample. So you can draw a counterexample pretty easily. So I can draw a quadrilateral that is tilted, but it still has four congruent sides. That's actually called a rhombus. So this is not specific enough. So you want to be concise, like use the least amount of phrasing as possible, but you also have to be specific enough. So a square not only has four congruent sides, but you also have to have right angles. Okay, so you would actually need to add on to this. So it has four congruent sides and four right angles. And then that would be specific enough to define a square. So let's try a couple more. These should be familiar to you. They're very basic vocabulary for angles. Probably been doing these since elementary school, in fact. So right angle. So we're going to define that. Right angle is it's classified as an angle. That seems pretty obvious. And specifically, a right angle is an angle that has a measure of 90 degrees. Okay, there is a specific symbol that you will notice in pictures indicating a right angle, and that is a little square in the corner. So whenever you see a square in the corner, you can assume that that is indicating a right angle. So over here, this is a right angle, only because you would have a square there. Don't ever assume it looks like a right angle unless you have the square or unless it indicates that it's 90 degrees. Okay, acute angle, again, is a type of angle. And an acute angle is an angle that measures between 0 degrees and 90 degrees. A lot of geometry books will just say less than 90 degrees, but we're just setting you up for the fact that there are negative angles. You'll get into those next year. We are not going to deal with negative angles, but officially an acute angle is between 0 degrees and 90 degrees. Okay, in a picture, you may not assume that an angle is acute, unless you know what the actual measure of it is. Let's say this is 48 degrees. Therefore, we can conclude that this is an acute angle. Next, an obtuse angle is an angle that measures between, and then this one is between 90 degrees and 180 degrees. Okay, so again, in the picture, you may not assume that this is an obtuse angle unless you know what the measure is or it says that it's obtuse. So let's say this is like 122 degrees. Then you would know that was obtuse. Okay, next, so parallel lines. Parallel lines are obviously lines. Okay, and then they are lines that do not intersect. However, you know from our previous notes that there are also skew lines. Skew lines also do not intersect. So we do have to be more specific than just say do not intersect. So to differentiate from skew lines, they do not intersect and are coplanar. So parallel lines are always going to be in the same plane. Whenever you have parallel lines, you can always set a flat surface on those parallel lines to make a plane. Okay, the symbol for parallel is sort of this tilted 11. Okay, so in this picture, if we were given the fact that these are parallel, the statement we could write is DE. The line DE is parallel to the line FG. Okay, the other thing that you need to look for, if you are not given that these are parallel somewhere, if you have arrows on the lines, in the middle of the lines like that, that indicates that those are parallel lines. You may never assume parallel lines unless you have this symbol or you are given some kind of information about it. Okay, skew lines. So skew lines are obviously lines. Now, I only have one line here because skew lines, they don't intersect. That is true, but skew lines are non-coplanar. So all you have to say actually is that skew lines are lines that are non-coplanar because that already assumes or implies they do not intersect. If lines are not on the same plane, there is no way they are going to intersect. Okay, so remember, we talked about skew lines in a previous lesson, but for example, if you have this line right here, and then you have this line down here, no matter how long you extend those two lines in that picture, those are not going to intersect as a three-dimensional representation. Okay, so those are skew lines. There is no symbol for skew lines, so you would just have some sort of statement that would say like EF and is that a BC? It's hard to tell. BC are skew. Okay, next. So perpendicular lines. Again, they are lines. And the most important part about the lines for perpendicular is that they intersect to form right angles. So perpendicular lines are lines that intersect to form right angles. Okay, you don't have to say anything about being coplanar because if they intersect, that automatically implies that they are coplanar. So you can just put a little right angle symbol in the corner like that, and that will tell you that those are perpendicular. Also, there is a symbol, just like for parallel lines, there's this sort of tilted 11. Upside down T means perpendicular. So in this picture, you would say HJ, the line HJ is perpendicular to the line IK. That's an arrow. Okay, so those are your different types of lines. Okay, and then lastly, just going to sort of explain through these guys. Complementary angles. So the most important part about complementary angles is that it has to be a pair. It has to be two angles exactly. Can't be 3, cannot be 4. It has to be two angles whose measures add up to 90 degrees. Now, these do not have to be adjacent angles. They can be adjacent, meaning next to each other. They can be, but they can be completely separate angles. They just have to add up to 90. Same with supplementary. So it's a pair, has to be two angles that add up to 180 degrees. Again, you would need to know that they have specific angle measures, or stated that they are supplementary. You have to have some evidence that you know they're supplementary. Vertical angles. So this actually has a really complicated definition. So we're going to read through it and sort of explain it, but then we're going to ignore just the technical definition and just go with the shortcut definition. So vertical angles in this picture, these are vertical angles, angles 1 and 2. So technically it's a pair of angles formed by intersecting lines. So we have two intersecting lines and they share a common vertex. The vertex is the corner of the angle, but not a common side. So what that means, if I just highlighted, for example, angle 2, remember a side is a ray. So this is one side of angle 2, not a side of angle 1. This is the other side of angle 2, also not part of angle 1. So they do not share a side of an angle, but they share a vertex. Now, you're never really going to use that definition from here on out, so you can just sort of ignore it, not worry about it. Really, the important part is that they are angles that are across from each other when you form an X. That's all you really have to identify in a picture, and you may assume that lines are straight, so it's not like when you see this line that there may be one little crink of 1 degree off. You can assume, there's not much you can assume in geometry, but you can assume lines are straight. So if it looks like a line, it is a line. Linear pair. So technically, so this is a picture of a linear pair. Technically, it's a pair of angles. So again, it's a pair of angles that share, that should say share a vertex. So here's the vertex that they share. And they share a common side. So again, this right here would be a common side to both angles. But their non-common sides form a line. So notice that their non-common sides here on the bottom, those form a line. Okay, but really the general definition is that two angles that make a straight line. Okay, so again, you can just never mind this very technical definition and just remember the shortcut definition. Okay, and again, you can always assume that lines are straight. So if you see a line and there's two angles forming that line, you can assume that that is a linear pair. You can't assume very much, but these two guys here, you can assume to be true as a vertical angle and a linear pair in a picture. Okay, everything else up here, you may not assume. You have to have evidence of them, especially the parallel lines and especially the perpendicular lines. People get those wrong all the time because they assume them without having the evidence. You need evidence to assume those things. Okay, same with all of these angles. You need evidence to know they are those special types of angles. Okay, so that's definitions and a little bit on what you can assume in geometry. See you later.